final review sheet. And it's based off of standard 1A, which states students know how to relate the position of an element in the periodic table to its atomic number and atomic mass. Let me give you each a periodic table. Pass that. There you go. There might be an extra for Robert. Yeah, just pass those back up. The atomic number. Great, thanks. Is, so take a look at this key, and it shows that the atomic number is a whole number. There's no decimals. And also, it's the smaller number. Let's write that in. The atomic number is the whole number on the periodic table. Periodic table for each element it is smaller, it is than atomic mass, which is the decimal number, and indicates the number of protons. Now, protons are inside of every atom. They're not going to be on the outside, but the inside. Kind of like the Tootsie Roll in a Tootsie Roll Pop. It's that middle center that's very hard, but very dense. It's in the center. So let's draw ourselves an atom. Atoms can be thought of as like a ball, like a basketball, or like a tiny marble. And in the very center are protons. So draw them like smaller circles or a smaller ball. And you can shade in maybe like half of them. And those are protons. So the atomic number is the whole number on the periodic table for each element. It is smaller than the atomic mass, which is the decimal number for each element, and it indicates the number of protons. Protons have a positive charge. If it wasn't for protons, there wouldn't be electrons. If there wasn't for electrons, then we would not exist. Okay? We're made up of electrons. We're made up of protons. Now, the unshaded parts are neutrons. And neutrons have no charge. If there wasn't for neutrons, then the protons would push each other away and everything would fly apart, because positive and positive, they don't attract. What do positive and positive do when they're in contact? They'll repel. So these two pieces, protons and neutrons, you must have them, otherwise nothing would exist. There'd be nothing there. Protons will fly apart. And when you have this center, you're going to have electrons, and usually they're flying around. We're going to point at just the outer edge. Electrons, let's say always moving electrons. Put in quotes. Scientists can never track where an electron is exactly because it moves at the speed of light. And there's a charge on this electron, and it's attracted to positive. So what charge is that? It's attracted to positive. It starts with an N?
Negative.
Negative. Negative. Electrons have negative charge. Now, atomic number is different than atomic mass because protons and neutrons make atomic mass. Right? Atomic number is just protons, but atomic mass, that's both neutrons and protons. The atomic mass is describing, yes, the atomic mass is describing what's that center called when it has protons and neutrons inside? The nucleus. Atomic mass is describing the nucleus. Okay, that is enough to start us off. Now, my students have seen this review guide before, but we are going to do it again together, okay, with this newfound knowledge. Those who already know the answers, go ahead and fill it in, but circle in red pen the answers. Pass those over. You get another one even though you're in my class. This is now the after-school review guide. You need one more? Any extras? Good. There's an extra. How many? There's one.
You can write them.
Yeah, you can write on these. Yeah, make sure everything is in red. That way I know it's not the same one that you did during chemistry. Actually, write after-school tutoring at the top if you're one of my students. That way you'll get credit for it. Extra credit. Okay, go ahead and answer 1 through 4.